Hello guys, welcome back to Techdose, and in this video we will see the vertical and horizontal scaling, which is from basics of system design. Let's take an example and try to understand this concept. Let's assume that we have a ticket counter and there is only a single person which is handling the entire ticket counter. So people will be making queue. So I have made person P1 to P4 and they are all standing in queue. So people will be entering from one side and the tickets will be fetched from the other side, just like it happens in a queue. Now let's assume that the efficiency of this person at the ticket counter is to handle 5 person per minute. Or let's assume each person is taking 1 ticket, so 5 tickets per minute is its efficiency. Let's say this is the efficiency of any average worker who can handle the tickets. Okay. Now if we as the owner want to increase the number of tickets per minute which it can be handled at the ticket counter, then we may be hiring somebody more efficient, and let's say we have hired one of the most efficient person who is, let's say, 2 times faster as compared to the previous average employee, and he can give a throughput of 10 tickets per minute. Okay, so this is the throughput of this person who is one of the fastest. So if we are trying to improve our entire system by these kind of choices where our system do not actually expand, but we replace the system with a more efficient system. So in this case, the employee has been replaced by a more efficient employee, but the number of counters haven't increased or the number of employees haven't increased. So this can be considered as scaling vertically. This is vertical scaling. In the form of computer systems, if you have, let's say, 4 GB RAM, and if you want to upgrade, so let's say you have removed this 4 GB RAM and you have placed an 8 GB RAM, and later on if you again want to upgrade, then you have replaced this 8 GB RAM with, let's say, 32 GB RAM. So this is called scaling vertically, where you have the same computer system and you are just upgrading on the RAM or processor or anything, right? So this is called vertical scaling. Now coming back to our example of the ticket counter, if we wanted to get a very high throughput, now can we get a throughput more than 10 tickets per minute? Since this person who was hired is one of the fastest, so definitely we cannot expect it to handle, let's say, 20 tickets per minute. It is not possible, and we cannot hire such employee. In such a case, what if we make 4 counters? So C1 to C4 I have already made, so here we are increasing the number of counters. And what if we just hire average employee who can handle 5 tickets per minute? Then in this case, the total number of tickets which we can handle in aggregation will be 20 tickets per minute, which is 2 times the fastest person can handle. And even we can increase the number of counters by whatever count we want to actually increase the throughput with, right? So in this way, we actually have control over the entire load, how we want to handle it. We will just add on more systems, and these systems you see are not the most efficient systems. Here the person whom I have hired is just an average employee, so easy to get, and it will be cheaper to hire them, and all of them together get the job done, right? So this kind of scaling is called horizontal scaling. When it comes to your system, let's say you have a CPU, and this CPU is having 4 GB memory. Now if you want to scale up, then we can also do it in such a way that we take another CPU with, let's say, CPU 2, where we have another 4 GB of RAM, and let's say if we again want to scale up, we can have another CPU 3, which has again 4 more GB of RAMs, right? So in this way we are scaling the resources by adding more number of systems, and these systems are generally cheaper commodity hardwares. So they are very easy to buy, and it doesn't hit a lot on your pocket as well. And the good thing about it is you can scale them up as per your need. But in case of vertical scaling, you will hit a ceiling and you will never be able to scale up beyond this ceiling point, because as we saw here, that we cannot go faster than the fastest person in the world. So this is the basic meaning of vertical and horizontal scaling and the basic difference. Let's look at some of the important points of comparison. I would like to announce about our live training programs, data structures and algorithms, which is Interview Dose, and system design, which is Design Dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. If we talk about scalability, you already got an idea that if we are talking about just a single system and just updating the hardware or the software there, then that is basically the vertical scaling. But if you talk about horizontal scaling, then we are adding more a number of systems, and those systems can also be geographically separated, and therefore we have an control over how much load we can handle. We can exactly scale up if we want to handle more, and we can also scale down if we want to handle less. Therefore, in terms of scalability, horizontal scaling has a very big advantage. Now, when it comes to the cost you need to spend upfront, now since we just have a single system in the vertical scaling, therefore the amount of money you need to spend initially will be less as compared to horizontal scaling, where you will have to buy multiple systems. Okay. When it comes to future proofing, let's say that you have a vision that your software will definitely be scaling up and you will need a distributed system to handle that. In such a scenario, if you are using the strategy of vertical scaling in the beginning, then you will have to eventually you will have to change up to horizontal scaling. Now, if you are using horizontal scaling from the very beginning, then it will be very easy to scale up. Okay. So horizontally scaled architectures are actually future proof if you think about scaling it up on the scale of large systems, large distributed systems. Okay. Now let's talk about flexibility. Now when it comes to flexibility, I'll take two parameters. One is changing the configuration. Now since you just have a single machine on vertical scaling, therefore having multiple configuration on the same machine on the same piece of hardware is very difficult to manage. However, if you consider the horizontally scaled system, you will have multiple system and you will have like multiple configuration. You can have multiple configuration for multiple machines. So easier to run multiple configuration on horizontal scaling as compared to vertical scaling. If you also talk about the updates, then on a vertically scaled system, you will have a single system. So either it updates or it remains at the same version. Generally, this is what actually happens. But if we talk about the horizontally scaled system, here we can have independent machines actually upgrading, and some of them may be at the same version and they will later upgrade. So in this case, we have more control over the updates, and it is more like a continuous process instead of the vertical scaling where you either upgrade or you don't upgrade, like 0-1. Okay. When it comes to geographical distribution, definitely if you are doing vertical scaling, you have a single system, so it is present at some part of the globe, but it cannot be present everywhere. Now if people are present in some other region and they want to actually query from your software or your hardware, then they have to travel a long distance. Their packets have to travel a long distance and there will be higher latency. In case of horizontally scaled system, you can make them distributed and multiple servers can be present at multiple global places, so that even if users are remotely located, there will be some server who are close by, whom they can contact and get the job done with lower latency. So this will actually improve the quality of service. So horizontal scaling is better in this case. If we talk about the reliability and redundancy, then vertical scaling, since it has just a single machine, it will create a single point of failure, while horizontally scaled system will be globally distributed, and also they will maintain multiple copies of the same data or the same piece of work, and their hardware will also be duplicated, right? Therefore there will be no single point of failure, and if one of the system at some location goes entirely down, then you can again make it up, and again it can copy all the data and whatever was required from the other redundant systems. So in this way it will be very failure resistant as compared to the vertically scaled system. So I hope this must have given you an idea and a comparison about vertically scaled and horizontally scaled systems. Like and share our video and subscribe to our channel in order to watch more of these system design videos. See you guys in the next video. Thank you.